Welcome back. We're talking about logistic regression. We're looking at a data set, and this is video number, I don't know what, in a series of videos. It's part of a playlist. If you're coming at this for the first time, don't worry, we'll catch you up in just 2 seconds, and you'll be well on your way to understanding what we're talking about. So first of all, logistic regression, you've got a binary outcome, in this case, diabetes or not diabetes, and you've got multiple possible predictor variables, and you want to know which of these and which combination of these may help us predict the outcome variable. And that's what logistic regression is. This is the data set that we're using. You have access to this data, by the way, if you're working in R. Install the ML bench package. This is the data set that you then have access to. You can replicate everything that I'm doing at home. It's the best way to learn. Right. I will also at the end of the video put a link, and you can click on it and get access to this page. And that will mean that you can look at this code. You can even copy the code straight into RStudio. There's copy and paste function, and there are these little annotations. So you can hover over the annotations, and it gives you an explanatory note about all of the code that's there. Okay, and how I create, and even the data viz, I've got all of that there. Now, on this YouTube channel, we're creating R programming videos on everything. We started off with just a model, a simple model, where we just had one variable, glucose, right? So as glucose goes up, the chances of you getting diabetes goes up, right? And here is our probability distribution. And incidentally, this is the model, right? That's the model. Now, here's the code that we use to create the model, and here is the output, and we can see, boom shakalaka, glucose has got a positive relationship as we'd expect. Now, we want to start building the model, and we've already spoken in a previous video about adding a single variable to the model. So what did we do? We added down here, we started with glucose, we added in age, okay, and we took note, right? We took note of the fact that age was statistically significant, and that the residual deviance and the AIC both went down, all indicating that this is a good thing to add to the model at this stage, to the best of our knowledge. Adding age is a plus. The model has improved by adding this one variable. Okay, so that's interesting. So we can add in a variable. We've also talked about adding in interaction terms. So here in effect modifiers, we said, look, let's not just add age as a single variable, but let's, in here you put a multiply or a star sign instead of a plus. Let's add age as a possible effect modifier. And essentially the effect modifier here sort of says, well, as you get older, the way you metabolize glucose changes. Distribution, interaction terms, and